Hello again. Today we're looking at the scooter and it doesn't turn on. It's already been had a go at, so I'll just prove it to you. I believe the battery is charged. If we push the power button there or hold it down, nothing happens. And there's our throttle. So I'm going to push that when I kick the wheel because these things don't start spinning until there's motion detected. So we'll give that a spin and then push the throttle. And nothing. Definitely nothing. So not sure what's happened. There's a little bit going on in there, but it's certainly not the guts of the motor driver. I think that's probably going to be contained in the front hub where the motor is, or possibly down in the bottom of the housing, maybe where the handlebar attaches. I don't really know. It could even be under the platform with the battery. I haven't looked. But this is what we need to start with, so let's do that. So what I'll do initially, meter leads and start probing around, and let's see what we have going on. Any activity perhaps? So what have we got there? I'd say this is going to be, this is our throttle control coming in, so we can ignore that. We have this here, which I think is possibly serial comms to the motor, or maybe a speed signal from the hub. And then we've got this, which I believe is our power in, and there's some other wires there as well. And this connector on the left with all the black wires, that just goes up and into our front LED for our headlight. So what we'll do first is we'll probe here. So we've got a red and a black, so let's see if there's anything on those referencing, and we'll check the others too with reference to black. We'll say black's probably ground, and we'll see if there's anything there. So black to red. Oh, there we go, 41 volts. I believe it's fully charged pack, so they're about 42 volt pack. If we go to yellow, we've got nothing. Green, nothing. Blue, still lots of nothing. Having a look at what's going on around here. If this is our LED output, there's an inductor here. It's probably being switched by, I think there's a little IC underneath here, and there's a diode there. So it could be creating that rail, and then down here we have another inductor here, a couple of caps, and another inductor over here. We've got this IC here, which is like going to be another buck converter to run the processor on this board. This will be, I'd imagine, a Bluetooth module, because a lot of these scooters have apps to connect with them. This is a Reid, R-E-I-D is the only thing I can see written on it at this point, brand. So we've got a MOSFET there, another diode, more diodes. Yeah, there's not too much going on this board. So we might need to take a closer look and see what this is supposed to do. Should it always be switching? Perhaps it should also always be running. I'd imagine we should have like 3 or 5 volts on here all the time. Maybe we pop the board off and have a look at the other side. There should be some voltage on the power button for a start, otherwise it wouldn't know we're pushing it. And what do we have on the other side? Oh, well, that's going to do it. Hey, that's really going to do it. Can I get any? Look at that. Look at it's crusty. Liquid damage will get you every time. Well, that's good, because that means that's probably repairable right away, and I shouldn't need to order any parts. Alright, let's, yeah, I think I'll disconnect the battery at this point, because we can't work on this with power there, and these, unfortunately, don't plug in, so I may have to desolder them just to get the board off to be able to work on it at bench level. Alright, well, with the bottom off, you can see the battery. And ooh, it's advanced lithium pack. None of this basic lithium pack stuff. There we go, hooks up into here. A bit of tape wrapped around some join there. But there's our controller for brushless motor. All 36 watts rating, I believe. No, at least that's stamped on the side of the motor anyway. Let's unplug this and we should be safe to play with it. That slides up inside that half there. So, and this is quite flimsy, so it's kind of self-defeating when you're holding the side of that and trying to pull the other half out, but you're squeezing it, so you're squeezing the sides against it, so you're kind of fighting yourself. Double check that we're on the right track. Oh, still got 15 volts there. That might be coming out of the motor controller. If this is fed from the motor controller and the power goes directly into that, there could be some residual on there. I'm going to need to try and drain that away. Whoops. Well, I forgot to push record, I guess. But we are now down at half a volt, 1 volt. There's really no capacity in that. Well, it just peered down the top here and I could see a couple of plugs. So I thought I'd just undo the couple of screws on each side. And what have we got? What have we got? Look at that. Look at that. The whole head just unplugs anyway. We could have left the battery attached. And there, are they the same plug? They better not be. Oh no, we've got green and yellow. Here we go. Can't mix them up. But that will allow the board to come off quite easily. So there you go. If you're working on one of these, and you probably find most scooters are going to be the same for ease of assembly and so forth. You don't need to unplug the battery, just pop that off. Well, that's what we're dealing with. And hopefully that's all we're dealing with. Looks like the worst of it is cornered. And here, hopefully those components are salvageable, at least the values, so we can put new ones on. We can maybe measure them for values. Where does our switch attach? Okay, so you can see the top left pin of our switch comes down to here. So this is why it's not registering a button push. This is all munted up. So we're going to start with a basic clean. A bit of alcohol and a toothbrush should get the worst of it off. And that's, if this is some sort of, it is serial. Look at that, TX and RX. Ha, I knew it. Okay, so there's serial comms from here down to the controller. What do we got for a processor? It's interesting. There we go. There's a big chip under there. That just could be a display driver. Maybe. It's under that side there. It's probably our display driver. Or maybe this is our... maybe this isn't Bluetooth. Maybe this is our module, our control module. We have some text on there that's very faded. If I just peel that off, maybe. We have some conformal coding. We have a crystal, and I don't see what might be considered a path to an antenna. So that's probably our main chip. And no Bluetooth, no app interaction on this model perhaps, which is fine. It is it's an ST, oh yeah, blue NRG 1, or is that a 6? Wow, color me wrong. It's a wireless system on chip, so there is Bluetooth integrated into this at some point. But yeah, that probably handles everything. Alright, well, let's start with cleaning. And nice and gently. We don't want to rip any parts off and lose them, although it's probably just a couple resistors with values that would suit either being pull up or pull down or what have you. Conformal coating wise, there is a bit on there, but it clearly didn't do anything. A bit of a dribble. We can see on the right it actually says RGB and 5 volt. So LEDs must be multicolor. It's already brand new. Started to get under the solder mask on this side too. There's a rust forming on the leg of that transistor. I mean, the component itself is probably absolutely fine. You can see on this resistor here, you can see the white stripe there. That used to be a connection to the resistor material on top. So that's eroded away, and possibly the same on this one. We've definitely lost a lot of the end of it there. So hopefully we can just probe up against the carbon on top and maybe get a reading off it. Give me a rough idea of what it should be as a value. And has that got under the solder mask, or is that just under the conformal coating? There's a bit of staining there. Might just be under the coating, I think. I guess the only thing to possibly worry about is the fact that over here we have 42 volts VBAT. That's quite a potential. So if there was liquid in here, 48 volts on the data lines is probably not ideal. There's a diode there and a diode there. Although I don't think they're actually connected to the data lines. I thought maybe there'd be protection, maybe a Zener or something. So there's a slim chance we have a problem there. Let's hope we don't. So I think our main issue is those two resistors, and then this thing will probably turn on. Let's try and get a value. and that's not looking very promising. It's pretty much completely destroyed. I'm not getting a reading off that at all. Alright, so there's that one. And the switch is across there. So the top two and the bottom are joined together, and the bottom two are joined together, and we have one's going to be ground, which I think is the bottom, with ground being there. So if I just edit there, nope. Oh. $4K. That's not good. I would have thought that that would probably go to ground. So this is connected to that side of that cap. This side of that cap appears to be ground. If I just check that, and it is. So this goes through a resistor. There's a rather large trace here, and then it goes to, does it go to here? No, it doesn't go to there. It doesn't go to there. It doesn't go to there. Okay, where's that going to? Is that ground? Okay. Okay, so the bottom half of the switch goes through a resistor to ground, and the top of the switch appears to just go to this resistor, and that goes off to an unknown, probably straight out through here and down here. So the process is on the other side. Let me just see if I can see where that traces go to. It goes over to the middle, and then that one goes off to, runs off and out the side to that pad, and possibly nowhere. So that might, okay, so that's probably a blank pad for some other reason, but other than running off to a no pad, we have that resistor there, and that goes off that end of that transistor. So I'd imagine that what we're probably doing is that resistor is holding that line to ground, so that when we push the button, there's a voltage there that gets passed through a lower resistance than that one to the other side of the switch, and then down to that middle trace, which is, if I flip it over, I'm going to say probably that. That right there, that wire there, that goes up through a big fat trace off to here, which could be some kind of regulator or something that then toggles to say, hey, turn on. Something happens there, so the micro can see that there was something happen, and it says turn on. There's a diode there, but that's only, I'd say that's probably sending power out to whatever that connector goes to, probably a sensor. And so this is a main power supply there. So that's actually feeding out. So if that's feeding out, well, that's confusing again too. So if that's actually feeding power out, and that's where that trace goes, which I'm pretty sure that's where that trace goes, what we could probably do is stick some voltage on there where the battery comes in, and see what voltage we have here. Maybe work out a suitable resistor. I'd say it's probably going to be less than this value. Probably. Because this is wanting to pull it to ground. And when it's joined together, this would have to be a lower value to encourage current to flow away from here. Or from here, this would have to be possibly, yeah, I don't know. I wonder what value this is. Let's measure this one. 4.6K in circuit. That's 4.6K. I still think this is going to want to be less than that. Can I try and get a reading on this one? It's too far gone as well. Nope, that's not looking good. Oh, definitely got under this solder mask. It's discolored. I'm sure it's still connecting through though. Just looks bad. Get rid of some of that grotty old solder there. Some more of this conformal coating. Better hit the record button, eh? There we go. Let's get rid of that. Oop. And that one. See if we can clean up that pad a little bit. And that pad is totally missing, I think. Oh no, there it goes. Looking silver again. And then we'll stick a wire on there and we can run some power into this board and see what it does. Get a wire on there. And on the ground. Better add a bit better solder to that. Now I don't have 48 volts, 40 volts, sorry. I have 32 volts, which is hopefully going to be enough to give us an idea. I mean, this thing's going to have buck converters that are going to run as needed anyway to give us what we're supposed to have on this little board at least. I'm not trying to drive the motor with this. So it draws no current in idle. And if we check what voltage is going on here, yellow ground, and over here we have 0.6 of a volt. What's on our base? Nothing. On our emitter, nothing. There we have half a volt. So that's kind of strange, isn't it? How's that getting through there? Does that come through to somewhere else? Who knows? But if we check on there, we have 32 volts. Okay. So that's why that was pretty corroded. That gets the full battery voltage up here. Nothing on the switch, and of course nothing there because that's pulled to ground. So surely we're not switching 32 volts through to the processor. Maybe we are. Maybe this resistor divider is supposed to pull that all the way down. Seems like a lot to rely on to not blow the input on your micro. But it could be a high voltage micro, who knows? Maybe I should check the data sheet. What else have we got going on here? Anything on there? Got nothing on there. Nothing on there. And 0.3 there. Nothing there. Nothing there. So at the moment we're looking at full voltage through to the on-off button. Let's do a bit of a calculation and see what it would take to drop that voltage down to maybe 3 or 5. But also look at the data sheet on that as well. Curious as to maybe that chip is just a high voltage chip. That's why they use it. So that's it. And operating voltage is 1.7 to 3.6. So it's not going to be happy accepting 32 volts on a general purpose I/O line. So we need to figure out what's going on, how that transistor plays a role there, and yeah, try and follow that line to see where it goes. But we've got 4K to ground, so we need to figure out the rest. I don't know, seems a bit rude to, or it seems a bit crude to rely on just a resistor divider, I guess, but maybe it does the job. Let's follow that line from the switch. So it's this pin goes through here and around the corner and down to the middle of the board. Remember that both sides of the switch are joined, so I'm just going to probe off the other side and poke around. We can see there's I thought it came up here. It doesn't come up here. Doesn't come here. No. There's a skinny trace through one here, so that via is about the middle. That goes through to this resistor here. Aha! So then it goes through that resistor into this transistor, which here we are. So it's operating this pin. So this is going to act as a buffer. This pin's going to be probably 3 volts out of the micro. This transistor is going to pull it to ground when it receives something on the base or gate, whatever it is. And we have what looks like a diode. If I zoom in on that, oh yeah, with the cathode on the base. So that could very well be a Zener. So maybe that's part of the circuit to drop this voltage as well. We could test this theory by ramping up the power supply off the end of this and seeing what voltage that it goes to Zener at. That could be fun. It's not going to do any damage because if we go straight across the diode. Maybe we do that as a bit of an experiment, and that way we know what voltage that we need to aim for to be a bit less than the Zener voltage on this. Or maybe I not be so crude and look up a data sheet. It looks like 3MP. What's a 3MP? There must be a Zener. They wouldn't need a diode like that in a circuit like this, in that configuration. What's the number on that one? 1YC7. Oh, we'll go 1YC. If this is believable, 3M on a diode is 160 volt Zener. And apparently the transistor comes up as this. And what rating is that? Max ratings. Ah, lovely. 40 volts max and the 160 volt Zener. That's not going to work, is it? Maybe I've misunderstood the that's not it physically, but nominal voltage. It doesn't tell me what the breakdown voltage is. The Zener voltage. It doesn't tell me what the Zener voltage is. What do we got? SMZ. Ah, okay. But I said SM. Oh, sorry. 3MP crossed over as this. Oh, that doesn't help me at all. But we know it's a Zener. It's got to be a Zener. So maybe a little test we can do just to force back feed it and see what its Zener's at. So we've got positive on the left, negative on the right, and I'm just going to gently turn up the voltage until we see some current draw. I suppose 50 milliamps should be safe, but we just need to see where it starts to break down. Power on. Let's go up in 1 volt increments, and we're already capped out at 1 volt. How about that? Let's go in 10 millivolt increments. Half a volt, nothing there. 0.6, 0.7, 0.8. 800 millivolts is when that starts to conduct. And at 900 millivolts, it's in full clamp. All right, 800 millivolts it is. So now I guess we just need to figure out what resistors we need to get about 0.9 of a volt or 1 volt out of 32 volts. That resistor that's above the diode is just going to be current limiting for the diode. Curious to see what that is, if I haven't already measured that. Let's just have a look. What have we got there? 1K. Okay, that's fine. To do it right, I really need to know what this value is exactly. So that's the value to ground off the switch. So let's desolder it and find out for sure. Now, there you go. Leave one end tacked on so we don't lose it. Oh, it is exactly 4.6K. There we go. And we'll definitely put that back so we don't forget about it, so we don't accidentally leave it off and have no voltage divider and blow everything up. Make sure it is attached at both ends. It is, and that one's ground. Wonderful. 4.6K. So if we go to little calculator website, because I'm lazy, 42 volts in, 1 volt out. We know 4600 goes to ground, which is R2. So R1 is going to have to be about 188K. 180. What's close to 180 something K? Standard resistor values, because you can't just pick every imaginable value. 180K, 200K. Right. So what if we plug in 200K? It's the closest. Calculate. 0.944. Well, we know that 0.8 is clipping it, so maybe 220K, 0.86. It might be a bit nicer on the old diode to not have too much thrown at it. This is the best I can do. It's a little big, but as you see, I can just jump across there and mount it on an angle. It'll still do the job. And then we just need something from there to there. And it won't be the end of the world. Before we put that down though, we'll put down some solder mask. Clean up that mess. Make it look a bit better. Our mask is nice and cured. Let's get some solder onto the leg of that switch, because that's where we're going to mount this thing to. Find out where I put this not so tiny resistor. And plonk it on. Ooh. Thereabouts. Alright, and we can flood down the bottom there. And to make sure it's attached at the bottom, we'll just heat up the top, and it shouldn't move until enough heat goes through the resistor and melts it. Now we need to figure out what to stick between this one and this one. We don't even know what that does yet. Maybe, I mean, it's pulling the same line, or it's pulling that to ground. Why would it want to pull 32 odd volts to ground? That center pin must go somewhere else. Do we have to take that transistor off to figure it out? Clearly, the right hand pin goes to ground. We have the base controlled through a couple of resistors there. And then the collector is just pulling that to ground. There must be a wire underneath that transistor that goes to the collector, surely. Took the transistor off. Only to discover nothing. Bit of a corroded pad, but other than that. So it's clear that this is used for some kind of control of the power line. And I'm going to hazard a guess that it is security. Because if your phone app hasn't paired with it successfully and unlocked it, you can't turn it on, because this transistor is going to pull the 40 odd volts to ground, and there's going to be no voltage here to switch through to the other side. I reckon this is just security. So that's cool. We can work out a resistor value based on that would comfortably pull it to 0 without frying everything. It's coming directly from... Where's it coming from? I have to find out where it's coming from to see what sort of resistance we have in between there and there, unless maybe I can just take a resistance measurement between VBAT pin and here. See what we got. 10k. So it has to go through at least 10k to get here. I don't know where that resistor is, and I really don't care. But if we have 10k there, we go to here, 10k from the source, which is that one. Oh, and we want to take that away, and we want an output voltage of nothing. We can't have nothing. What about 0.1? we need more than point. So it's going for about 0.1. Because we need more than that. So the other divider is going to be quite a lot anyway. So we could go for 28 ohms, maybe. Quite a low value. We could probably even go for like 10 ohms, and that would give us very low value. And there's going to be no current flow at 10k. So let me find a 10 ohm or thereabouts, and we'll shove that in there. Although, let's not, because what's going to happen is I don't know how to set this up. And if I can't get the app to pair with my phone, then it's never going to unlock, is it? I obviously have to unlock it first with a known good to be able to make it work. Okay, it wasn't turning on. We know that there was liquid damage, so I'm just going to say overlook that we didn't have the original phone to pair with, and expect that maybe I'm going to leave this transistor disconnected for now. I'll put it back in circuit, but I won't put the resistor there, and we'll see what happens. Do I want a hot air all over the place? I don't know. Might just sort of wick that away. Reattaching the bench supply, we've only got, as I say, 32 volts to play with. So hopefully it's enough for some limited functionality. 400 milliamps should be heaps. Alright. And on. Okay. And if I push the power button, will anything happen? Nothing. Oh no. It doesn't even show a current draw of any sort. That's interesting. Maybe it doesn't power on outside of, or maybe it has to actually be 42 volts. I'll just show you this. So let's look at the switch, and when I push the switch we get 0.6 almost, 0.556. That should be enough to turn on, but at least our voltage divider is within cooey. Let's plug it into the scooter and see if the 42 volts is enough. Alright, we have battery connected. Let's see if that's enough voltage to turn on. So if I hold it down, it does that. Let's see. Oh, I've got a tail light lit up. Let's see if it's Bluetooth is in pairing mode. No devices found. Probably not good that the tail light's always lit up. Oh no, it just turned off. And now it turned on. I wonder if it's on but not displaying. So it's kind of half working because a long press is supposed to turn the lights off and on, which it does with a tail light, but I think I'll go ahead and put a resistor on that other transistor and see if it does anything. Maybe there's some kind of timing event that has to be triggered. Alright, will it go? Haha! Okay, so who knows what that's doing without putting an oscilloscope on it and seeing what happens, because as we saw, it's only connected the power signal to ground, but anyway, it's upside down too. And now if I push the button, it should... What's it going to do? Nothing? If I hold it down... Oh yeah, we've got a light on the front. I don't know, I've got a red light there, and I've got a red light there. It could be locked. But let's just spin the wheel and see if it does its thing. There we go. Oh, it is running on a very low speed. So that's full speed. I don't think that's fast enough. If I hold that down, it doesn't do anything. If I push it, it doesn't do anything. Is it getting hot? It doesn't feel like it's getting hot. Well, there still could be a problem, but at least it turns on. Maybe it has to have an app connection, although it wouldn't drive if it did. I don't know. I'm just going to let it sit for a bit and see if it turns itself off. I just measured there where I added the resistor. That transistor is turned on, but with a 10 ohm it is pulling the voltage down too much, and so it can't detect a change in the switch. When I push the switch, it doesn't detect the change. Because there's no voltage there to detect it. So I need a bigger one that doesn't pull it down so much. So I'll have to practice with a few values, I think. Okay, I've gone for 200 ohms, which should leave us about 0.7 or 8 volts for the switch to play with. So let's try that. Now it doesn't turn on at all. Okay, it's a new day. I'm not tired, and I was filming at night as usual. So, with a fresh start and a lot less brain fog, thinking about it, this 220k is too high. So, remember when I measured from battery voltage, our battery in to this point, and I said we've got 10k ohms. So I was trying to find a resistor based around 10k that when this turns on, we wouldn't have, would have a desirable voltage here. Completely overlooked the fact that that 10k plays a part in this switch as well, because it's 10k to here already, plus 220 plus 4.6 at the other end. So that's too much. I need to consider the 10k that's already in to here when the switch is pressed. So let's see what voltage that would leave us if the 220k was just a short. Having a look at our divider again, source voltage of 42. Resistance 1 is going to be 10k. Let's just use the values we've got, and resistance 2 is 4600. And that's going to give us 13 volts. Probably a bit high for our Zener, even though it's very low current. It would probably react rather quickly. It would be dropping 13 to 0.8. So what if we had 10k plus, it would probably be 80k really. 80k, 2.2 volts, it's a bit better. Maybe it should be like 100k. Maybe the 200k is probably too much, double what we, that's down to 1.8. I mean, surely it can clamp. 1.8 is not going to be that much of an issue. Yeah, let's try that. So if we got 1.8 when the switch is pressed, and what are we going to have when the transistor's turned on? That was dropping it to like 0.8 as well, which means 0.8. Yeah, I wonder if that would work. Okay, let's try 100k and see if it's more reliable. Okay, I'll have to use two 200k in parallel. I could stack them end on maybe. And that should measure 100k, and it does. So with that in mind, what do we need for a value here? Because when that's on, we're going to get a different voltage. It's not turned on when the unit's off. So there's always going to be a higher voltage for initial switch on. What if we had 13 volts up there? That would give us half a volt. Oh, yeah, maybe it should be 13 volts then. Maybe it should be 10k. Because 10k would give us 13 volts. And 13 volts would then drop down to, or 13 volts would drop down to about 4 volts. Oh, that could be a better option. Okay. Well, after all that, I might swap it out for 10k. 10k and 1k. All right. Let's do this again. So what I think I'll do is I'll just series up my bench supplies and try and get it working on here instead of running back and forwards to the scooter. All right, let's see if it'll switch on the bench. Ah, look at that. Okay. Now let's see if it'll respond to button push. It did. See the number 1 change to a 2 and a 3 and a 1. And if I hold it down, it turns off. Okay, lights on, double click. Lights off. 3 clicks, it shows mileage, I believe. And then 3 clicks again, it changes back. Okay, so that's now responding as we would expect. And you couldn't really see that. I'll show you that again, just to prove it. It's a bit tricky with the... Hang on, let me unplug that. Okay, so it is actually blinking to say low battery. So I'm just going to increase the voltage gently. And it's still not. So we're at 32, 42, 43, 44. Okay, let's just stay at 41. That blinking could be an error code because it's not connected to the rest of the system, so that's fine. So if I double tap and you see the light come on for the headlight, and then hold it down, turns off. Hold it down again, turns on. 3 taps, we get the thing. And back. Okay, there we go. So you can see that's functioning there. Just a reminder, we're using 10k ohm from the B plus to the switch and a 1k ohm from the switch B plus to the transistor. I'm just going to do a quick measurement and I'll let you guys know what voltage is on here while it's turned on, and it's 3.7. So it's interesting to note, 3.7. So if we had a look at our circuit calculator, so we got 3.7 going through. Effectively, it's just 10k on the switch and 4600 to ground. What's coming out the other end? 1.1. Okay, so that's fine for the Xena to drop as well. There we go. I think that's a winner. The green connector has the power on it, if you're wondering. I'll connect the other one first, just because, but I don't think it really matters. It doesn't power up in an on state. Okay, all hooked up. Let's turn it on. And again, we're upside down. Let's just... and we're showing full battery charge. So it did need to be hooked up. It was blinking this one before. So we have a tail light on. If I double tap that, we now have a headlight. Let me just show you that there. See, my hand is lit up very brightly. Interestingly, that was red before. So if we double tap that again, it is red now. So with the lights off, we have a soft red light in the front and a red light at the back, which does get brighter when you pull the handbrake. Now the way this reads, the 1 is first gear, so that's why I was only getting a low speed before. So I'll give it a spin, and so full throttle is 9 k's an hour. Can I change speed while I'm moving? Let's push the button once. Look at that, kicks in. So full throttle on second gear, they call it. 18 k's an hour. And third gear, 25 k's an hour. A little bit of a vibration there. It's not a perfectly balanced wheel. But here we go. She's working. Fantastic. There we go. I wonder how we get the miles an hour. Maybe you have to hook up to the app. Doesn't appear to be connected to the user's app anyway. It's not locked. So that's good. Let's get it back together and call it a day. Well, that works absolutely perfectly. And it gets along just fine, and it's got a slow acceleration to it. Gets up to about 20 in the length of my drive on third gear, so to speak. But that's fine. I'm sure they'll be very happy, and they will have to learn not to ride it in the rain. Well, I hope you enjoyed that. Thanks for watching, and see you next time.